Okay, so this will be a long class, and we are going to try to cover all the topics that we have discussed in this particular course. So, first of all, let me break the question pattern. So, there will be so you have full marks of 80. Okay. So this is breakdown to 8 questions, each having 10 marks. Okay, so each having 10 marks. So there are 3 sections. So group A, group B, and group C. So this is practical or program based. So practical based or programs. Here you have to answer 2 out of 4. Okay. So there are 4 programs, pretty basic programs, and you have to answer any 2 of them. Uh, in this particular section, group B, you have theoretical questions. So theoretical questions, and you have to answer 4 out of 6. Okay, so there will be 6 questions and you have to answer 4. And in group A, there will be this questions will be basically short answer type. Like what will be the output of this particular code, or some basic questions, basic small questions. So this will be group A, short answer type questions. Here you have to answer 10 questions out of 14, I guess. So each carrying 2 marks. So 10 multiplied by 2, that is equal to 20 here. Here 4 multiplied by 10, that is equal to 40, and 2 multiplied by 10, that is equal to 20, that sums up to 80. So this is the breakdown of your questions. Now I have covered everything that I have taught uh, in the classes only, and nothing else. There will be no extra questions, nothing from the syllabus, only those things will be there that I have taught. Okay, so let's start with the topics. So first of all, some basic knowledge about computer. So basics of computer. So we know that a computer is a system. So it can be uh, thought of like this. So a computer is a system where we give some inputs and we get some outputs. Okay. Now this particular section is known as CPU, Central Processing Unit. And the devices that are connected with this CPU is known as input devices and output devices. And the CPU is divided into 2 categories or 2 sections. So one is a memory. So this memory, we are talking about RAM here. That means we are talking about primary memory. In programming, whenever we use this particular word memory, we are always referring to a RAM. Obviously there is some secondary storage and all these things, but that is another part. So you can call it, this memory part can be divided into 2 parts, where you have a RAM and you have some secondary memory like hard disks. Okay, so you can divide it that way. And this particular unit, so this is our CPU actually. So this is our CPU, and this CPU is again divided into 2 parts. One is called ALU, another one is called CU. So ALU where all the processing is done. All the processing is done in ALU. ALU stands for Arithmetic Logic Unit, and CU, that is your control unit that actually gives signal. So it is something like ALU does all the operations that our brain does. Okay, that means all the calculations, all the decisions are made by ALU. What is control unit? This is something like our neural system. So that gives signals to all the other parts or peripherals. So what are those peripherals? These are inputs, outputs, and memory. So CU is responsible for giving signals to all those components, and ALU is the main core who takes up all the decisions on behalf of the computer. So this is a basic structure of any computer. Now we know that computer only understand 0 and 1. So this is only computer understands. Why? I think I have discussed this reason. Why? Because it can only sense whether there is a power in the circuit or not. So that's why 0 and 1. 1 means there is a power, 0 means there is not any power. So computer understands only 0 and 1. So at the beginning of development, to interact with the computer, we have to give signals in zeros and ones. So we have to tell computer everything, how to do it and what to do it. So computer doesn't have their own brain. So we must tell the computer that what you have to do, and also we have to mention how it can be done. So a program is basically a write down instruction or written instruction to a computer that can specify or that can make computer learn that particular thing. That means by writing a program, we give an instruction on how to do some things. So suppose, for example, suppose you are trying to write a program to add two numbers. So you cannot just give two numbers and computer will produce the result. So there is a calculator for that. So calculator is already programmed by that way. So what we are trying to do by this class, we are trying to learn how we can give those instructions. So those instructions are given by programs. So all those instructions together actually called a program. So in initial days, the programs were written in 0 and 1s. So those 0 and 1s, or the combinations of 0 and 1s, is called machine language. Or machine level language. So there are three different generations of programming languages. So initially there was machine language, that is a combination of 0 and 1s, and it is very hard for humans like us to understand this combination. If one combination is wrong, you have to enter the whole combination again. It might possible that one bit is flipped in some way. So it was taking months of effort to write a single program. Then the computers have started to develop, and we have moved into another programming language or another generation of languages that is known as assembly language. So what assembly language provides us with some efficiency in reading, like it is a combination of alphanumeric codes. Alphanumeric codes Alphanumeric codes means it is a combination of alphabets and numbers. For example, suppose add 5,6. So the instructions was looking like this. Like there is alphabets or some alphabets or collection of alphabets that form some keywords, and using that keywords we do some operations like add 5,6. So this was assembly language or generation 2 language. After that, the programming languages and computers develop further enough or high enough to produce high level languages. That we nowadays use. So high level languages are example of C, C++, Java, and all the other languages are all high level language. And what it does, it actually written in English language. So mostly the languages or mostly all the instructions are written in English. Okay. But the fact that machine only understands 0 and 1 doesn't change throughout the year. So that thing doesn't change. So what we are changing? We are changing the languages. Why they are called language? Because it is used to communicate with the computer. That's why the language terms is used. So high level languages are efficient enough and easy to understand by humans very easily. So they are used for our own benefit, not the computer's benefit. Computer has a disadvantage here. Computer has to convert this English languages or this high level languages into machine level languages. Similarly, assembly languages are also needed to be converted to machine level language. So that conversion from assembly to machine level conversion is done by assembler. So a conversion is actually required because machine cannot understand beyond machine level language. That means it cannot understand beyond uh, machine language or the combination of 0 and 1. And also this high level languages are also converted. These high level languages are also converted into machine level language where we apply two kind of translators. So we have to apply translators. One of them being interpreter, another one is compiler. So we have this two type of system for translating high level language to machine level language, and they are called interpreter and compiler. So what is the difference between interpreter and compiler? So what is the difference between interpreter and compiler? Interpreter is line by line execution. So it executes the instruction line by line. That means one line after another line. And compilation, what it does, it translates all the instructions together. So it actually translates all the instructions together. Similarly, if interpreter interprets line by line, that means finding an error is easy, as well as debugging is easy. So bug means error, debugging means resolving that particular error. So as finding errors is easy because that particular line that has some error will be shown and will be displayed by the interpreter or interpreted at that particular time. Whereas in case of compiler, as everything or every instruction, a set of instruction is compiled together or translate together, so it will be hard to find the error. Not for the compilers, it is for the developers. It is hard to find the errors for the developer, and debugging is also difficult, comparatively difficult. Okay. Now, for interpreter, execution process is slow. Execution process is slow, or the whole. Suppose we have 100 instructions. So to execute and translate these 100 instructions require more time in case of interpreter. Why? Because one instruction is being executed one at a time, or interpreted one at a time. So that's why you have to resolve all the errors and then only you can actually come to the 100th instruction. Whereas in case of compiler, the process is fast. So the process is fast means the compilation process is very fast because if there is no error, you can actually compile all the instruction all together. You can translate all the instruction all together into the machine code, and the process will be faster. So these are the differences between interpreter and compiler. Most of the programming languages actually uses compiler. So our C program actually uses compiler. So now we are slowly moving into C programming languages. So in C program, what we do, we write a code. We write our codes or instructions using C language. So we call it, or the file will be end with .c. So this is called source file. So this source file we are going to write. So we are going to write the source file and save it as a .c file to indicate that this is a C file. And we apply C compiler here. So we are going to apply C compiler here. And that C compiler will produce an object file. The extension will be .obj, and this object file will be then going to produce executable code that is known as our .exe file. So we apply here linkers and loaders. That means when this object file is loaded into the memory, we have found our executable code, and this particular code is going to execute and produce some output for our program or do some job depending on whatever instruction we have given to uh, the to the compiler or to the computer basically. So we write some instructions here, and our executable file is actually generated to perform all the tasks that we have given to that particular program. So this is how a C program basically executes. Now let's look into our first C program. Uh, so so let's look into our first C program. So first C program. So it will look like so I said this, I'm telling this again, hash include this and hash include this. Both of them does the same thing. Both of them includes a header file. So what is a header file? Header file contains some of the information, some of the libraries that are given to us to efficiently write some program, like how to print. We don't have to write how to print. We know, or we have some facilities to print something on the screen. We don't have to write that particular code. So we have some instructions or some information given to us, or some tools given to us. Those tools are written in stdio.h or whatever header file we have, or the system has. So we must include some header files to have facilitated to that particular tools. Like for mathematical functions, we have a header file names math.h. Similarly, generally, for all the C programs, we include stdio.h. That means standard input output header file. So this header file contains all the methods, all the tools that are required to take inputs from the user and show or display some output to the user. So that's why we must include header files, or we should include header files that are required for some purpose. Similarly, for string handling or manipulating string, some functions or some tools were there, and those tools are written or can be found in string.h header file, and this is small. So there are two ways to include something. to your or include a header file to your program. One is hash include with angular braces, and another one is hash include with double quotes. So what is the difference between them? The difference is that hash include angular quotes actually checks the default directory or the default library. That means where the C program is stored and where all the C default libraries are there. So that folder is being checked. But when we include this, so hash include this quotes, so what is happening, if you provide this, so it will first going to check your current directory, that means in which you have written some program or your program is saved, and if the header file is not found in that particular directory, it will search the system directory or the default library. And the reverse case is, in case of Angular bracket, it will first search the system directory, then it might search the current directory. So there is a difference between those two, and string.h is basically used to have or to get the facilities of string manipulative functions. So let's continue with our first program. So hash include stdio.h and then void main, say printf. So this is our tool. I'm going to discuss that. Hello world. So this could be our first program. So now we are going to dissect this particular program. So this particular line is known as pre-processing. This particular line is known as pre-processing. So this particular line is known as pre-processing. Pre-processing means some process that are done at the time of compilation. So there are different pre-processing directives, like we have hash define. So this is also another pre-processing directive. It is used to define constant. Like if you write hash define max 10, what it does or what it tells to the compiler, that max, whenever it found or it finds max, this particular word in the program or inside your code, it will replace that max by 10. That means this is something like a constant. So hash define is used to create constant in program. So this is another example of pre-processing. So now this particular area is known as global section. Global section means if you define something, if you define a variable here, it will be treated as a global variable. Global variable in the sense that variable is accessible from anywhere in the program. Why we are calling this anywhere, and what is that? This is called the scope of a variable. So we are going to come to that part later when we discuss about variables. So for now, just assume that this is a global section where if you write something, it will be accessible by anything within that particular file, only within that particular file. Okay. Now, all C programs starts with this particular function. This is called main function. This return type will be varied. So void is a return type. So that means is in this particular scenario, void main means this main function will not return anything. If our main function to be returned anything, like suppose an integer or suppose a floating type value, that means a real number or something like this, we must put that particular type here. So void means nothing. So generally we use a void main, or you can actually use int main as well. But whenever you use int main, that means your program is expected to return something. So to return something, we must use a return statement. So return 0. So this particular statement will be used to indicate that, or whatever value you want to return from that particular program. It depends upon you, but we generally do these two things. If you define main function as an integer, that means it returns an integer value, then you must put return 0. If you don't, if you define it as void, you don't have to include this. So this is optional. So this is optional. So either you can write int or you can write void, depends upon you. So generally, if you want to remove one extra line from your program, you can just include void. So it is your choice. So now so all the program starts with this main function and ends at this particular code. So main function is treated as a block, and main block starts here and ends here. So it denotes the start of your program and it denotes the ends of your program. All the programs start with this main or this brace followed by the main and ends at the brace that is closing the main. So this particular section is called main block. Okay. So this particular section is called main block. Now inside the main block, whatever information or whatever instruction you are going to write, they are going to be executed. Okay, if something is written here, if some codes are written here and some codes are written here, and if you don't have any reference to that code inside the main, they are useless for that particular program. That means if you write something here, and if you don't mention them inside the main, that means they are not usable for that particular program, and the program will automatically ignore everything. Okay, so this is the main block, and inside main block we put some instructions. So some instruction in the sense write something on the screen. So that is the instruction. So this is our instruction. So we have given an instruction that is write something on the screen. That means this printf function. So printf is a predefined function. So this hello world, what it does, this printf function directs the computer or the system that write this particular word or this particular string basically. So everything enclosed within a quote in a C program is treated as a string, and everything enclosed within a single quote is treated as a character. So this is to tell or to denote the computer that this particular word has to be printed, or this particular string has to be printed on the console. And while executing, after compilation, while executing that particular code, our computer actually does that particular thing. So all the instruction we write inside the main will be executed by the compiler. Now let's look at some terminologies. So if someone has any problem or any question, they can raise their questions, no issues. So I am assuming that you guys are understanding everything. Yes. Yes. কিছুই effect হচ্ছে না. That program is not returning anything. It is printing, it is doing its job, but returnটা কোথায় করবে? Return, that is the question. Where this particular value will be returned? This particular value will be returned to the calling. বলো. না. That is not written. That is a task. That is a task that is performed by your main function, but that is not returned. This particular function is not returning anything. So when you learn what is a function and how they work, so function has two things. They can do some task, and also they can return something to its calling function. So if we have some other function, suppose a function for finding the power, so we write this power function a comma b. So this function is actually returning something. This power function will return a value that must be captured. But printf is nothing like that. Whenever a function is returning, we actually capture that value. Like suppose in this particular case, int c is equal to power of a comma b. That means we are capturing that particular value. This particular power function is returning some value and we are actually capturing that particular value. But in case of printf, you don't write something like this. That means we are not capturing some value. That means printf is not returning something in this particular case. But actually printf returns something. That is the number of character it has printed. So here in this particular scenario, printf will return 1 2 3 4 5 6 7 8 9 10 11. So it will return 11, but that particular number is not necessary for us or not necessary for the programmer, so we don't store that particular number. So what you can do, you can actually store that particular number. Suppose int a is equal to this, and you can return that particular number through the main. So that is returning. That means this particular function is being returned. It is doing its job. It is printing something and then counting how many numbers or how many letters it has printed on the screen, and that number is being returned using the return statement. But where it will be returned? It will be returned to the calling function. But in case of main, we don't have any calling function and we don't have any mechanism to store that particular function. For that, we actually don't return anything and we tend to use void. We actually don't use int. You can use int, but that doesn't serve any purpose. Okay, so that will not serve any purpose. If you use system calls to call this particular function, that means if you use system methods to use or execute this particular program, then it might require to return something to that particular system call. But we are not using any system call, we are just executing for our test purpose. So in that particular scenario, we actually don't need any value from the main. So either you can declare it void, because actually we don't need any value from main. So in other programmings like Java, we don't have that option of int. We only have the option that void will main will not return anything. So main always becomes void. But in C, because it was written very early stage on early stage, where in some system calls there was a need to return something from the main, that's why it was there. But in nowadays we actually don't need that int main. We can have those void main, and printing doesn't mean it is returning something. It is printing. It is a job to. So I am giving you, suppose I am giving you 100 rupees and saying pay this rupees to someone else. Okay, so what you are doing, you are just doing what I am trying to, or what I have instructed you. But if I ask you just return buy something, that means do something with this money and return the rest of the amount. So that is returning. That means you are returning something to me, so that is returning. And when you already consuming all the money and doing whatever I have instructed to you, that doesn't mean instruction, that doesn't mean you are returning something. But if you are returning, or if you are giving a feedback to me, that means I have done your job, that is a feedback that you are returning, so that is again return. But if you don't give me the feedback, that there is no return in this particular scenario, that means you are doing my job. I am instructed you to do some job and you have done it, and I know you have done it, and I don't need your acknowledgement, or I don't need your response. So that is not no return. So printing doesn't mean returning. Return means some value will be returned by the program. Clear? So return and print. So print is an instruction that do this job. That means do print something on the screen. That doesn't mean return. Clear? Okay. So let us discuss some terms that are related to programs. So first of all, let's discuss statements. Statements means individual instructions or single instruction. So a statement is a single instruction and always ends with a semicolon. So it always ends with a semicolon. Okay. So statements are single instruction. That means an instruction like printf hello world. So that is a single instruction. So it can be considered as a statement, and it has to be meaningful and complete. So that is how a statement is, and all the statements always ends with a semicolon. Then comes block. So block is a collection of statements. Okay, so a block is a collection of statements. That's why we can say this is a main block. That means inside the main function we have a collection of statements. So that's why that is a main block. So a block starts with this. So block always starts with this. Sorry. Starts with this and ends with this. And ends with this. So a block always starts with this and ends with this. Then we have programs. So a program is also a collection of statements and blocks. Okay. So a program is a collection of statements and blocks, or you can say instructions. Okay. And in case of, especially in case of C, a program, or rather we should write it something like this. A valid C program must have main function. So a valid C program must have a main function. So we have learned statements, that is a single instruction, a block, that means anything enclosed within this opening brace and closing brace is treated as a block. And a program is a collection of statements or blocks or instructions, and a valid C program must have the main function or the main block. Okay, so this is some of the terminologies that used in programming. And then we have the smallest part in a program known as tokens. So tokens are the smallest individual unit that has some meaning. Okay, so tokens are smallest individual units that has some meaning. So this can be treated as words in English. And also we have character set. Character set means all the alphabets that are supported by any language. So all the programs, all the languages actually have those. That means if you consider English language, it has alphabets A to Z. They are called character set or alphabets, and forming or combining these alphabets we form words. So words can be considered as a token here, and then combining words in a meaningful way we create uh, a sentence. So similarly, a statement is a combination of tokens in a meaningful way, and that meaningful way is defined by, in English, if you consider this, it defined by grammar, and in case of programming languages, that is called syntax. Syntax, it is a rules or set of rules to create statements. So syntax provide us a set of rules to create our statements. So we have to follow our or the programming language's syntax to how we can actually create some uh, statements or some instructions.
So the smallest part in a program is actually tokens. You can consider it to be a
Words. So in grammar or in English, you have parts of speech. That means each word is classified into one of these parts of speech. Similarly, tokens are also classified into some categories. So these categories are
literals, token, sorry, it's not tokens, keywords,
operators, identifiers, assignment,
special characters,
white spaces. So there is this many types of tokens. Uh, I I might not forget anything. So let's discuss every one of them. So literals are basically constants. So these constants can be of three type. So this constant can be of three types. One is number one, string literals. That means everything enclosed within double quote. Say A. Number two, character literals. That means everything enclosed within a single quote. Number three, so I am not going into details because this is not a detailed class, so I am not going into details. So strings means anything enclosed within a double quote. It is a constant value. That means that particular value will not change throughout the program. Then we have characters. Uh, so anything enclosed within a single quote is a character, but if you enclose A and B together, it is not a character. This is not a valid character. Only one character is allowed, or only one character set, or one element from the character set is allowed in a character. So, in this character set in C program, the character set includes A to Z, then 0 to 9, and all the special characters including white space. Okay, all the special characters that you can see on your keyboard is actually a character set in C. So there is total of 128 ASCII character sets. In some updated versions, there are 256 characters that are supported by the character set of C. So
uh, then we have integer,
literals, so that represents the whole numbers like 27 minus 253 and so on. And then we have real literals that are fractional numbers, basically 2.37 minus 3 minus 3.0 minus 2.1, something like this. So this four type of literals are available in C. Then comes this keywords. Keywords are the reserve words. That means some words or some tokens basically reserved, and they cannot be used for your own purpose. That means user cannot use them for their own purpose. So these reserved words may include or includes basically for, while, do, then break. These are some of the examples of reserve words. So that means these words are, you can easily find out, there might be 48 or 46 something like reserve word. You can easily find out those reserve words or the list of reserve words on Google. So you can just Google it, you will find it. Then comes identifiers. Then comes identifiers. Identifiers means naming. Oh yeah. So we have forgot the precious things, that is data types and variables. These two are very important and we have forgot them. Okay, so identifier means name, not naming. It will be actually name. Name, that means some label. So you can label some variable, you can label some function, you can label some class, you can label some structure, you can label some array. So all these things is called labeling. That means giving a user defined name to some object or some entity inside the program is called identifiers. So so variable is one of the identifiers. Identifiers and variables are two different things. Identifier is, in general, naming or labeling something is called identifiers, or something that can be labeled, like a variable, a variable, a array, a function, a structure, a union. So all these things can be identified. That means they can be given some user-defined names. They can be labeled differently. So they are identifiers, and variable is one of the identifiers. So variable is different thing. So what is a variable? So variable is a placeholder in memory. So variable is a placeholder in memory. That means inside the memory it creates some area like a storage. So variable is a placeholder inside the memory, and that can be labeled. So that can be identified with a label. Suppose we label this particular variable as A. So variable is a location, storage location, where we can use or we can write our temporary variables or temporary data inside those storages. Okay, and the variable is closely related to data types, because without data types we cannot have variables. So there are different type of data types. Data types defines how that placeholder will hold values. That means which type of value is going to be stored in those placeholders. So there are different type of data types, like integer data types. So data types can be classified into three sections, I guess. One is, okay, let's change the slide or change the page. So data types can be classified into three sections. One is primitive data type or primary data type. Number two is derived data type. And number three is user-defined data types. So primitive data type means the basic data types that are available within the library of C, like int. So int stands for integer, is used to store, or integer type of data, like used to store whole numbers. Okay, then we have float. and double. Both of them are used to store fractional numbers or real numbers. So what is the difference? The difference is on the size. That means what is the difference between float and double? The difference is on size. That means how many bits are required to store those values. So I am not going to discuss all of them because as you know we have to hurry. Then we have byte. It is the size of byte is smaller than int, and it is also used to store whole numbers. Then we have char. So char is used to store character type of data. That means if you are going to assign some values into the characters or character type of data, what you have to do, you have to just include those braces, single quotes. We don't have anything to store strings. So we don't have any primitive data type that can store strings. Then in the derived section, so derived data type means they are derived from the primitive data type. That means they are an extension of primitive data types, like, for example, an array. And string is nothing but a character array basically. Then we have pointers. Then we have functions. All those things are derived data types. That means they are derived from the primitive data types. And user defined means user can create their own data type. So there are two ways to create that: structure and union. So these two methods are there. I don't remember if I have taught structure or union. I think I have not taught the structure and union section in the classes. So you can skip this part. Not for this data type section, but as a overall of this structure and union section. So you can skip the details of structure and union. So there are three different categories of data types, and in these different categories, we have this kind of thing. Now let's go back to this variable section and let's check how we can actually define variables. So to define variables, what we have to do, we have to use the syntax. So what is the syntax of defining variables? So first of all, let's see the definition. For the definition, you have to write data type and then variable name. So this variable name is an identifier. The variable name is an identifier here. So data type and variable name. So for example, it can be integer a. Okay. So a is a data type, or a is a variable that of type integer. That means compiler now understands from this particular statement that a will be an identifier. A will be an identifier which can actually store an integer variable. Now integer has the size of 2 bytes. So what will happen inside the memory? What will happen inside the memory? A memory location 2 bytes. So it is a 2-byte location, suppose. 1 byte, that means 8 bit. That means a 16 bits of memory location is created and it is named as A. So this is what is happening when you write int A. Now comes the initialization part. Initialization means we have to initialize the value that is being, or we have to initialize the value of that particular variable. So for that, what we can use, we can use the assignment operator. So a is equal to 5. So when you write a is equal to 5, at that particular time the 5 will be written here. That means 5 will be stored in that 2 byte of space. So this is what is happening when you declare a variable and initialize it. And you can actually combine these two statements together to have a statement like this: int a is equal to 5. So these two declarative, or not definition, it can be called declaration. So this declarative and initialization step can be combined together to have this kind of instructions. Okay, so all these variable declarations are called declarative statements, and all the declarative statements should be placed before any other instruction. Any other instruction in the sense any other executable instructions. So these are not commands. So these are actually declarations of variables. That means you are going to use these variables in your commands. So these are not commands actually. Commands are like printing something, in taking inputs, doing some operation, doing addition, subtraction, multiplication. These are the operation. So those are called executable statements, and these are called declarative statements. And all the declarative statements must be included before any executable statement starts in any function. That means if you are writing the main function, where is it? So here. So if you are writing the main function, if you have inside the main function, if you need or if you require some variables, you must declare those variables in this particular section, and then only you can execute or you can start the executable statement. You cannot declare anything beyond that. Beyond, if you have a executable statement like printf here, you cannot declare some variable here. This is not done. You cannot declare that. You must include all the declarative statement at the beginning of the executable statement. Now for this variable name or any identifier name, we have some rules. The rules are: number one, rules for naming. যে একটা কুইজ টাইপের কোয়েশ্চেন আমি বলেছিলাম না, এক্সাম ইন্টারনাল, ওটা একটু ভালো করে করো। মানে ভালো করে করো ইন দ্য সেন্স কোয়েশ্চেনগুলো একটু মাথায় রেখো, পরীক্ষার জন্য কাজে দেবে। Rules for naming, that means how we can actually name this identifier. There are some rules. Number one rule is uh, can start, the name can start with alphabets or underscore. This is underscore, okay. No other character is allowed to start a very identifier name, okay. Only the identifier can start with an alphabet or an underscore character. Number two, it can include alphabets, numbers, and underscore. Okay, only this characters or this underscore character is allowed inside the name. That means you can put underscore between different words. Any alphabets, uppercase or lowercase, are can be used in naming, and numbers can also be included. But the name cannot be start with a number. It has to start with either an alphabet or an underscore character. Okay, so these are the things, or these are the points to be remembered while naming an identifier. Okay, so we have passed this data type, variables, literals, keywords, and identifiers. Assignments or assignment operator, you can say anything. So assignment is equal equal. So here we have L value and R value. This L value must be a storage. Okay, this L value must be a storage. Whenever you use assignment operator, this L value must be a storage, and this R value, storage in the sense it should be a variable. Simple. If you just simplify it, it should be a variable. That means a placeholder or a location or memory location. And R value can have constants, literals, variables. functions, anything. So R value can be anything, but L value should be storage location. And if some functions actually return some value, you must have a L value to store that particular value. So R value can be constant, literal, variable, functions, anything, but L value must be a storage location. That keep that in mind. And always this R value is calculated first. So this will be done first, and then this R value can be an expression as well. This R value can be expression as well, like suppose C is equal to A plus B. So here the R value is an expression, and C is a variable suppose, and A is a variable, B is a variable. So it is a expression. Expression is a collection of different operands or variables or anything. So a R value can be an expression, uh, but L value must be a storage location. Okay. Else we cannot store some value using this assignment operator. So this is tokens. Now this special character and white space. So special character means any character, multiplication, sorry, division, say plus, say ampersand, say has. Any character is treated as a special character. And then we have white spaces. White spaces means a blank space is also a character set in case of C. And sometimes white space is very important. Like in this particular situation, 8A is equal to 5, and we have A is equal to A. C is equal to A plus B. So these two statements are there. In this particular scenario, if you write C is equal to A plus B without any white space, this is absolutely fine. But if you write int A equal to 5, this is wrong. There, the syntax of variable declaration says we must include a space between the data type and the variable name. So sometimes white spaces are very important, and sometimes white spaces are not that important. Okay, so keep that in mind. That's why white space is also included in the character set. Now we move into the topic, that is operators. So there are different type of operators available in C, like arithmetic operators, like plus, minus, multiplication, and division. So see that multiplication sign, it is not this, it is a star that you can find on your keyboard on the right hand side on top of 9. Okay, so that is a star sign. So that is work as a multiplication operation. And we have this division operation. So division is not this, division is this one. Okay. And we also have the working of this particular function. This is called modulo operation. It used to find the remainder from integer, and this modulo operation is not applicable for floating point numbers. That means for real numbers we cannot apply modulo operation. It can only be applied to it can only be applied to integer numbers or whole numbers. So this
arithmetic operators are available there. So I'll just find this one.
because this is new. So how can we use it? Suppose we have a is equal to 5 and b is equal to 3, and if you write c is equal to considering it is int, and we have int c as well here.
And if you write
C is equal to a divided by b. So
and D is equal to A modulo operation P.
so this is the modulo operation. That means it will find the remainder. So when you divide 5 divided by 3, and you will find the remainder is 2. So the output or the value that will be stored in D will be 2. And what about this one? A divided by B. Now this is interesting. Uh, in a first glance, it should be, the value should be 1 point something, 1.66 actually. 5 divided by 3 is 1.66. But when you are going to print the value of C, it will print,
1.
it will not print 1.66. There is a reason.
For that we have
To learn expressions. Expressions are a combination of operators and operands. Operand in the sense it can be any variable, any constant, any literal. So they are the operands. So expression is a collection of that. And now there are two type of expression. One is called pure expression, and another one is called impure expression. Okay. So in pure expression, the output is always similar to the or the output from the pure expression is always similar to those of the operands that are used in that particular program. So pure expression means a particular expression that has only similar type of values. Okay. And impure means expression where we have dissimilar type of data. Like for example, so let's check the example of our pure. So it is 5 divided by 3 or 2.5 multiplied by 3.5. So these are pure expression. Pure expression means all the operators that are used in that particular expression are of similar type. So these are integers, these are floating or double, or basically real numbers. So this is a pure expression, as well as this is another pure expression. Whereas impure means we have a combination of multiple, say 5.0 divided by 3. So this is an impure statement or impure expression. Similarly 2.5 multiplied by 3. So this is another impure statement. That means we have two different type of values in a single expression or single equation. So that particular equation or that particular expression is called impure expression. And the interesting thing is that in case of
impure expression, the resultant value is always the value
that takes, or the type that takes maximum amount of storage area. So
float.
this is float and this is integer. So float always takes maximum amount of size from integer. So the resultant value of this particular expression will be a float value. The resultant value from this will be a float value. But from pure expressions, the resultant value will be same as the operand. So this is an integer type of data. 5 is integer, 3 is integer. So the resultant value will be integer. So that's why the precision is lost in this particular situation. So when you perform A divided by B, precision is going to be lost. Okay, but if we have a scenario like this 5.0 divided by 3 or 5.0 divided by 3.0, then the result will be 1.66. Here also the result will be 1.66. So you can say that if we use a double variable or float variable. So suppose you have a float variable e is equal to a divided by b, where a and b are basically integers. Then also it will have e will have 1.0, not 1.66, because it depends on the result here. It doesn't depends on whatever or what type of value we are going to capture. It is basically the value of the r value. So as I said, the r value will be calculated first, then it will be assigned to the left value. So it doesn't depend on whatever value or whatever type of value we are going to capture. It depends on what is the r value is.
Similarly, if you write int a
Is equal to suppose 5.3 divided by 5.0 divided by 3. If you write this, a will have 1, not 1.66 this time. Why? Because the resultant value from this particular equation is 1.66, but integer variable or integer data type cannot actually store or cannot accommodate this precisions. So this precision will be lost here. So it will be 1 again. So what is the solution? The solution is to have a floating type of value here to store the result from impure expression. Okay, so this is an impure expression and pure expression, and this is how things are going. And we have another concept called typecasting and conversion. So typecasting and conversion, what is this? So type conversion, let us discuss first. So this is called automatic type conversion. That means the types are going to be converted automatically. Like if you have a statement like this, float uh, a equal to 5.0, and then we have double b is equal to a. So as we know that double takes more size than float, this is the automatic type conversion. That means this value is automatically converted into
a double value.
Whereas if you just reverse it, like double b is equal to 5.0 and double sorry,
Not double.
float c is equal to b. So in this particular situation, it is not automatic type conversion. What we have to do here, we have to apply typecasting. That means manual typecasting. Manually, we can cast the type of one data type to another data type.
So what we have to write here? Float
C is equal to, we have to specify the data type, in which data type we are going to cast that particular value. So in this particular scenario, we are going to cast this particular double value into a float value. So float p. So in this particular scenario, it will be considered as data type casting. Okay. And this typecasting can also be used here as well. So, so this particular expression c is equal to
a divided by b can be written as float d is equal to, suppose int a is equal to 5 and int b is equal to 3 again is there. So what you can write, you can actually cast one of the values into a float
and then
divide it.
so in this particular process,
Sorry, a and b.
so we have casted the value of a to float and then divide it with an integer, so it becomes a mixed expression. And now the resultant value, so d will capture 1.66. So this is another example, or this is another way how you can actually get whatever you are trying to desire. So in this particular scenario, what is happening? A and b remains as it is. A and b remains as it is. That means a and b remains integer type of data, but the resultant value that we have wanted to have a float type of data or fractional numbers, we have got that. So this is another example of typecasting. An automatic type conversion is done whenever you are going to assign, or you have an expression with mixed data type. So all the data types will be automatically converted into the data type that has the larger size. That means in an expression between int, float, and double, uh, all the expression or all the data types will be converted to automatically double, because double has the highest size in that particular scenario. But if you have integer and character, so character has the lowest size, low size than integer, so character is also is going to be converted into a integer. So this is called automatic type conversion, and the example that we have seen here in this particular case is called type casting. বোঝা যাচ্ছে? ইয়েস, ক্যারেক্টারের ক্ষেত্রে অ্যাস্কি ভ্যালুটা নেবে। Then we have after arithmetic operators we have two more type of operators, and I am not going to discuss all other operators. So another one is relational operator. Relational operator means greater than, less than, greater equal, less equal. So mind that this is not like this. This is greater equal to sign. So greater equal, less equal, equal, equal. So this is equality sign. Why? Because this already belongs to, or this particular character already has a meaning, that is assignment. So to represent the relationship equality, we have two equals, and then we have not equal. So this is not equal. So all these relational operators returns either zero, not zero, either true or false. Okay, so false means zero, and true means any non-zero value. Okay, so if it returns zero or if it is returned false, that means you can say that this particular equation or this particular situation is not happening. That means if we have a is equal to 5 and b is equal to 6, if you apply this a greater than b, it will return 0. Okay, so if you just capture this, suppose int x is equal to a greater than b, the value of x will be 0, because a is 5 and b is 6. It is a false. But if you actually if you actually have, this is 15 suppose, so it will return 1. 1 means true. So either 1 or 0 or true or false, or actually any non-zero value is treated as true in C programming. So these are the relational operators. So these are all binary operations. That means you can have two operands in these operations. None of these operations can be done without two operands. And then we have logical operations or operators. Logical means they are logically correct or not. That means and, or logical or and not. And to represent them, we have something like this. For and, we have this. For or, we have this. And for not, we have this. So how this things done? So these operators also return yes, no, true, false, 0, 1. So what is happening? We might have a situation where you want to check whether a number is greater than, suppose you want to check x should be greater than 15 and also less than 100. So in those scenario, we have to use logical operations as well along with the relational operations. So what we are going to write? We are going to write x greater than 15 and x less than 100. Okay, so this is when this AND operations are useful. To combine two relational operations, we can use this AND operations. Also, NOT operation is special one. It can revert whatever effect is going to happen. That means if you write x greater than 15 and just put a not sign here, that means first of all it is going to check if I am giving x is equal to suppose 15 or rather 16. So the concept is that if the answer is from this relational operation, if the answer is true, it will make it false, and if the answer is false, it will make it true. It will reverse the effect. So what will happen? X greater than 16. So that means sorry, x equal to 16. That means 16 greater than 15. So this is true. That means answer is 1. So but we have a not here. That means from this particular expression, the answer will be 0. So it has reversed the effect of x greater than 0. Now, if the x is less than 15, the answer will be 1. So suppose if you have x is equal to 1, so 1 is greater than 15, that is false. So as this is false, this particular value will return true. So these are the different operators available in C. There is another category of operators. There are unary operators. So unary operators are there are two variations, plus plus and minus minus, and they also have two variations, pre-increment and post-increment. And minus minus also have two variations, post-decrement and pre-decrement. So they are unary operation means they require only one operand. Like a plus plus, this is post increment, and plus plus a, this is pre increment. Okay. Now what is happening in post increment, pre increments, and the same effect is on post decrement and pre decrement. So I'm not going to discuss that. I'm just discussing this a little bit. So a plus plus means post increment. So suppose we have a is equal to 5, and now you are writing z is equal to plus plus a, and in another situation suppose you have a equal to 6 and you are writing z is equal to a plus plus. So what will be the effect on these two variables? So after executing this particular statement, a will have the value 6 and z will have the value 5. Whereas in this particular situation, a will have the value 7 and z will also have the value 7. So what is happening here? So pre-increment means, okay, sorry. So pre-increment means the value is going to increment first. Increment means the same value is being incremented. That means we cannot apply plus plus 5. We cannot apply this unary operators to any constant because the value of 5 cannot be incremented. This can only be incremented, or this can only be applied for L value. So a plus plus or plus plus a is equivalent to a is equal to a plus 1. That means one value is going to be increased. But the position of plus plus before a or after a determines how this operation is going to work. So if it is plus plus a, so z is equal to plus plus a, it can be decoded as z. First of all, a is equal to, it can be decoded as a is equal to a plus 1 first, then z is equal to a. So this particular statement can be decoded as this, and this particular statement can be decoded as z is equal to a and a is equal to a plus 1. So this is what is happening. So in case of pre-increment, the increment is done first, then the value is being assigned to Z. And in the post-increment, the value is being assigned first, and the increment is going to happen after finding the semicolon. That means, and the next iteration or next instruction, A is going to be incremented. That's why In this particular example, the value of z is still 6 because the value has been assigned first. Then the value of a is being incremented, so a becomes 7. Whereas in this particular example, the value is incremented first, so a becomes a plus 1, that means 5 becomes 6, and then z also becomes 6 because the value is assigned afterwards. So this is the example of pre-increment and post-increment. So now we have learned all the tokens. Now just we have to apply these tokens and create our own program. And before that, we have to learn another thing, that is, so after learning this, we can take some break, then we will restart again from 8 p.m. Okay. So what we need to learn, that is input and output. So how can we take some inputs from the user, and how can we write or how can we print some output to our screen? So first of all, let us run how to take some inputs. Sorry, how to print something on the screen. So for that, you have to include uh, stdio.h. So this header file is required whenever you are trying to input something or print something on the screen through your program. So this header file must be included in your program. And the tool or the function that we are going to use to print something on the screen is called printf. There are other variations or other variable type of functions. We are going to discuss them later. So for now, just stick to one function, so printf. The first syntax is like this. So printf some string. So if you put some string here in this particular double quote, so that means it is a string literal. If you put something within this double quote, that particular value is going to be printed on the screen. That we have seen in our first program. Here, in our first program, we have seen this particular structure. Now, what are the different variations of printf? So there is a variation called, the full form of printf is printf in formatted manner, or printf print formatted. So that is the full form of printf. That means we can specify some format, and in that, on that particular format, we will get our output. So suppose what will happen if we have int a is equal to 5, float b is equal to 10, 10.0, and char c is equal to suppose a. So we have three different type of variables, and we want to print these variables on the screen. So first of all, let's learn how we can actually print some value. So for that, you have to write printf. Then there is a term called format specifier. You have to use format specifier to print some variable or the value of some variable using printf method. So format specifier for integer, we have %d. For float, we have %f. For char, we have sorry, not this. We have %c. And for double, we have lf. For long, we have ld. You can find it or you can learn it by your own. So these are the basic format specifier. Float for integer, %d for float, %f for character, %c. So you have to mention the format specifier within this double quote. Within this string literal, you have to mention the format specifier. Suppose you want to print the value of a. So I am writing a is equal to, so where in the place of that particular value, or the in the place of that particular variable, you have to mention the format specifier. So I want to print a is equal to the value of a, that is equal to 5. So a is equal to %t, and then you put a comma and mention which variable is that particular reference, or this format specifier for which variable. The variable is a. So if you write this particular statement, it will print a is equal to 5. And now if you want to print all of them, you can write it like this: printf, suppose a is equal to %d, comma. It doesn't hamper all the other string. Only the format specifier will be holding the values of the variables. It will not hamper the other characters you are writing on that double quote. Everything you are writing on that double quote will be treated as a string except this format specifiers. So b is equal to %f and c is equal to %c. Double quote ends, comma. Now you have to specify the variables. You have to specify all the variables, but in which order? The order will be in which the format specifier have appeared in the screen. So first of all, for this integer, so a, for this float, that is b, and for this character, that is c. So if you write this particular statement, the output will be a is equal to 5 comma b is equal to 10.00. Some zeros will be there. That depends on the compiler, that how many zeros will be followed by this floating point number, and c will be a. So this will be the output from this particular statement. So this is how you can print whatever you want using this printf statement. Okay, now for the inputs. So for the inputs, so this is only output. Okay, no problem. One second. One second. Okay. So for input, we have this scanf method. So scan formatted. So this is, oh sorry. ওটা বন্ধ হয়ে গেছিল। দেখা যাচ্ছে? Okay. So for input, we use this scanf function. The working of scanf is similar to the printf, but scanf cannot be used to print something on the screen. Rather, it is used to take some inputs, and also here you have to specify the format specifier. Suppose we have an integer variable, say int a. You want to input some value to this particular integer variable. So what you have to do, you have to write scanf, and s is small. So scanf, you have to use the format specifier. So %d, that is the value that we want to take from user. And also you have to mention the address where you want to store. For that, you have to use the address operator. So address operator is this. It is used to find the address, not find, used to get the address of a variable. So if you use ampersand of a, it will return address of a. Address of a where? In the memory. So from the memory, it will find the address of a and it will return that. So you have to mention the address of a. So in this particular scenario, you are mentioning %d ampersand of a. It will take input from the user into your variable. So suppose you want to take multiple inputs. So suppose you have int x is int x, then we have float y, and then you have char c. Suppose you want to take these inputs. So you can take them individually, or you can take them one after all together. So what you can write, scanf %d %y, %c. Don't specify anything in between them. That means no space, no comma or nothing else. Just specify all the format specifier all together, and then ampersand of a, comma ampersand of not a. In this particular case, it will be ampersand of x, ampersand of y, and ampersand of c. So all the addresses are being specified, and this particular thing will take inputs to your program. Okay, now we have learned mostly the basics of how to build a particular statement, how to build a particular program. Now we will going to incorporate everything into our next example program. Okay, but before that, you can take a 15-minute gaps or 15-minute gap, then we can start, or 10-minute gap, and we can start at 8. Okay, so program. You guys can leave and join with the same link, or you can stay here. It's up to you. দেখা যাচ্ছে শোনা যাচ্ছে? দেখা যাচ্ছে আর শোনা যাচ্ছে? Okay. So let's take a look at a program that is used to uh, calculate the sum of two numbers. Suppose taken from user. Okay, so calculate the sum of two numbers taken from user.
So
First of all, what we have to do, we have to include stdio dot h. So whenever we have a system defined library, that means system defined header file, we should use, not mandatory, but we should use this Angular brackets. And when we have say custom made or user made header files, then we can include with those
double quotes. So
include
stdio.h, and also one more interesting thing, or important thing.
we should avoid using any
Global variables. So what is
a
the
global variable. I am coming to that next. So first of all, let's complete this particular program.
so for this particular program,
We don't need anything extra. We don't need anything extra.
we just start our main program. So void main,
And main block starts. Here we have to decide on how we can actually give instructions to the computer or to the program, or give instruction to the computer so that it can calculate two numbers. So we have to give detailed instruction like we used to give to a kid, suppose, who doesn't know anything. So computer think computer as a kid and give instruction, so that those instructions, if you list those instructions, we can call it in a form of algorithm. Okay, so I am not going to discuss algorithm and flowchart again, but you have some questions on algorithm and flowchart, and you have those slides available on the website. You can find the lectures there. So you have some questions from algorithm and flowchart on your final exam. So
let's just chalk out some of the instructions that are very much important to the
program.
So first of all,
We
we
have to uh, declare some variables. Declare some variables. So we will discuss that later, that what are the variables. Then we have to input two numbers. Input two numbers. Number three, calculate the sum. Number four, display the result. You have to display the result. So these four are the major steps that we need to do in this particular program. So declare some variables. So what are the variables, or how many variables we require, and what are the data types? You have to decide at this particular time before starting your program. We usually do, we just roughly assume that these variables are required for this particular instance. Then you can just again come back to the uh, starting section of the main and write your rest of the functions, or rest of the variable. So for instance, or for this particular situation, we actually require three variables: one to store two variables, or two integer variables, or two double variables, or two float variables to store two numbers, and a third one that will store the sum. So for that, we are going to declare, suppose int a for the first number, int b for the second number, and sum as our third variable that will be used to store the third variable. Okay. Now we have to input these two numbers. That means we have to take inputs on A and B. So before taking an input, we must display the user something. We must show the user that something will have to enter. So we can put a comment here that means taking inputs. So this comment is used as a single line comment. So we have two different techniques to use comments. One is single line comment and another one is a multi-line comment that includes like this. Suppose you have included this particular line into your program before starting of this program. So this is a multi-line comment and this will be treated as a single line comment. So we have given a comment that taking inputs. For that, we display a message to the user. So printf enter two numbers, suppose enter two numbers, and then scanf. So we have to take two integers for that, two integer specifiers or format specifier for integers, and then ampersand of a and ampersand of b. Simple. So we have taken our inputs. Now the processing part where we have to calculate the sum. So write calculate sum. So in this section, we are going to calculate the sum. So the sum can be calculated as sum is equal to a plus b. So this is the operators that we have learned, and this is how we can write expressions, and this is assignment that we have learned, and this is the L value. L value is a variable. Yes, L value is a variable. So sum is equal to a plus b. And now we have to display. So display the result. For that, we can use the printf command. So printf sum is equal to %d, because two integers will sum up to another integer. So you can write ampersand of not ampersand. So whenever you are using print statement, you don't need to include ampersand. So sum equal to %d and specify what is the variable. So something like this. So it will print sum is equal to whatever value you have given. Now we can write this differently as well. So we can write printf. So just I am explaining that later. So this is our program of calculating the sum of two numbers taken from user input. Now, if you execute this particular code, the output will be something like this. So first of all, you are asked to enter two numbers. So you are given something like this. So enter two numbers. Now you will give one number, say 5, and press the enter button, and then you will give 10, press the enter button, and you will see that sum is equal to 15. Okay, so that is your execution, and that is the output of your program. So this is how you can write your programs. So the better thing is to chalk out some of the important statements or important instruction that you need to include, and then incorporate in that particular fashion. You can also use this particular statement printf a no no percent d plus percent d equal to percent d comma a comma b comma sum. If your print instruction is look like this, the output will be after executing this particular statement, that means 5 and 10, the output will be 5 plus 10 is equal to 15. So whichever you prefer, it depends on the programmer. So I basically, if I am a programmer, I will prefer this one because it will give the complete information to the user that which number is being summed up and then produce the result. So I will prefer this one. So some might prefer this one as well. So it depends on the programmer again. So this is how you can write your program. Now up to this point, anyone has any questions on regarding all the topics that we have covered up to this particular point? So this is our simplest program in C. Yes, you have. I forgot to mention that, so I will cover them on conditional statements, if else. Anything else? Okay, so let's move forward to the next section on. So we will learn control structure. I don't think it is possible to complete everything in one day. So we might need 2 or 3 classes at least. Uh, more, 1 or 2 classes more to complete the whole thing. So control structure means how your program is going to execute. So let's find out that. So in this particular example or in this particular program, we are going to understand what is a control is. The control means the instructions that are going to be executing next or currently. So the control means which instruction is going to execute next. So that is that. So the program actually doesn't starts with here or starts with this. All the programs always starts with this. All the programs always starts with this, and the upper part, that is hash part, is called pre-processing. That means it is used in the compilation process. The compiler will use that particular area, not the global area, but the hash part is depends on or is for compiler. So compiler use that particular area. So compiler will take care of how to include something or whatever the things are defined by this pre-processing. The program actual control or actual programming starts with void main. Okay, then the control. So I'm just numbering all the statements that are going to execute one after another. So this is the first instruction that is going to execute. Then this particular instruction will be the second instruction that is going to execute. That is int a, b, and sum. That means 3 memory references are created for a variable a that will store an integer, variable b that will store an integer, and for variable sum that will store an integer.
Now, this particular statement will not
Execute because this is not an executable statement. This is a comment line, and all the comment lines are basically ignored by the compiler or the executable code or the processor. Okay, so compiler will not produce any machine code for this particular line, so that's why this particular line is ignored. So it will not execute. So
what will be executing next? This particular line, number 3.
this particular line is going to execute next. Now, next.
This particular line will be executing, and then this one will be ignored. So this one will be ignored, and this one will be executing next.
And this one will be ignored, and this one will be
Executing
next. So this is the end. So after getting this particular thing, it will end. The program will end here. So program will start with this particular statement, void main this brace, and program will end when it encounters this particular uh, closing brace. Okay, so programming in. So this is the sequence in which sequence the program is running is known as control structure. and we have three different control structure. The one you have seen in this particular example is called sequential structure. That means one after another. So all the instruction in this particular block has executed one after another, except the non-executable one. So they are not taking part in the execution, so they are ignored by the compiler in translating them to machine code. So this is a sequential structure, a sequential control structure. We have two modes. So first one is sequential, that you have already seen. Number two is branch instruction, and number three is repetitive instructions. So you have already seen sequential instruction. We are going to only explore one example from each section. I am not going to discuss everything because that is not possible. So you have already seen sequential. In the branch instruction, we have two sections. One is conditional jump, actually three sections. Conditional jump, that means either you are going to execute some part of the code or just going to jump from that particular code. That means you are going to skip that particular code. Then we have two-way branching, and we have multi-way branching. Okay, and for repetitive instructions, we only have one option, repetition. That means it is going to repeat. And in this particular section, we call this loop. The tools that we use for repetitive instructions are called loops, and these loops are of two types. One is entry control, another one is exit control. So there is a detailed lecture on this control structure that you can find, not lecture, actually slide on this control structure on the website. You can find the details there. So there is entry control loop and exit control loop, and in the entry control loop, we have two tools that are provided by the C. One is for loop, another one is while loop. And for exit control loop, we have only one option, that is do while. I will discuss a little bit about them. And then we have this jump instruction. So for jump instruction, we have if statement. For two-way branching, we have variable type of options like if, else. And for multi-way branching, we have if, else ladder, if, else if ladder, and we have switch case. And this if else statement or any loop statement, they can be nested. Nested means within one if else structure, we can have another if else structure. Within one loop structure or iterative structure, we can have another iterative structure. So this kind of control structures are there. So let's discuss some of them. So we are going to discuss if else if, we are going to discuss switch case, not in details, but just for recap, we are going to discuss for, while, and do while. So when we are going to cover if else or if else if ladder, we are actually going to cover the if else as well. So if else if is used to represent multi-way branching. So what it look like? What is the syntax? So if else. What is the syntax of if else? The syntax is simple. You have if, then condition here. So a condition is a binary value, or rather a true false value. The value should be 0 or 1, depends on whatever say relative operation or relative operator or sorry, relative, no? Relational operator, or you have used logical operator. Depending on that, some value will be generated here, and that value will be either true or false. That means either it will be 0 or 1. So any zero value is considered as false, and any non-zero value, it is negative or positive, doesn't matter. It is always considered to be a true value. Okay, any non-zero value is always true. So if condition, within that you have some statements, and else we have some statements. So this is the basic structure of if else, where we have this condition and then some statements. Suppose statement set 1, and suppose we have statement set 2. So this statement set 1 will be, or is going to execute if this particular condition results in true. If this is true, so this condition can be true or false. So if this is true, this set of instruction is going to execute. If this is false, this condition is false, this set of instruction is going to execute. For example, if a greater than b, then suppose printf a is greater, else suppose printf b is greater. Okay, so this kind of situation like this. So if a is greater than b, this particular statement is going to execute, and if a is greater than if a is less than b, that means if this is false, this particular statement is going to execute. Now if your control is here, suppose if your control is here, so depending on this particular instruction, so suppose this is number 5, so number 6 instruction will be this, and depending on this instruction, either it will go to this or this. So suppose if the value of a is equal to 5 and b is equal to 2, so obvious reason is that so here we have some instructions, so this will be the control going to. So this is the instruction that is going to execute after this particular instruction, and the control will come here. So this particular instruction will be skipped. So this is the construction of if else. Now what is if else ladder? If else ladder means, and another interesting thing is that else is optional. You can either put else or you cannot put else. That is the if actually. So that is if. So I guess this is clear how control is moving. That means control will move either one of them. It cannot be, it cannot execute both the execution. So it cannot execute both the statements. It has to skip one of these statements. Now what is happening in if else if ladder? So it looks like this. If say condition 1, then else if condition 2, then suppose else. You can have any number of else ifs in between. In between this last else and in between this last else, uh, you can have any number of else if statements, and this one is also optional. Either you can put it or you cannot put it. So what is happening in this particular situation? In this particular situation, the control will move to one of this if statement, and uh, rest of the statements are going to ignored by the compiler. So if this particular condition is true, if this condition 1 is true, this statements or this section will be executed. If this particular condition is true, this section is going to execute. If all the conditions are false, If all the conditions are false, then this particular section is going to execute. So it depends on which condition we have, and depending on that, you can have only uh, one of these statements is going to execute. So for example, we can take a look at this particular code. Suppose you have marks is equal to 4 point, sorry, so suppose 85, and depending on this marks you are trying to find out the grade. So what you will write, if marks suppose greater than equal to 90, you will say grade is equal to single quote, suppose say E or O, suppose O, outstanding. Else if marks greater than equal to 80, then grade will be E. Else if marks greater than equal to 70, so grade is suppose A. Else if marks greater than equal to 60, grade is suppose B. Else if marks greater than equal to 40, grade say C. Else if not else if, so if the student doesn't have the marks uh, greater than 40, he is actually failed. So suppose grade equal to X. So you have this kind of statement. Now, if you have a single statement within a if block, you can actually omit this braces. So I have single statements on all the if blocks that is why I have not used the braces. So what is happening here? So the control is here. So marks is equal to 85. Now the control will move to one of this statement, and then it will move afterwards. That means suppose here you are trying to printf %c, say grade. You are trying to print the grade. Okay. So suppose this is instruction 5, or the control is this fifth control, or fifth instruction is going to execute. Now one of these instruction is going to execute depending on whatever value of this marks is. So as the marks is 85, so if marks greater than equal to 90, so that is false. That means this instruction is not going to execute. That means this instruction is not going to execute. Then marks is greater than 80. Yes, it is true. So that means this particular instruction is going to execute. Now, it will not check any of these ifs or not even else. Once a perfect match is found, it is not going to check any of these else conditions or any of these else if conditions, and the control will move. So it will be sixth instruction and it will be the seventh instruction. So this is how we can actually create a multi-way branch instruction where one of the instructions or one of the set of instruction, one of the set of instructions will be chosen depending on the condition you are provided. Now this type of activities can also be done using switch case. So this kind of activities or this kind of multi-way branching can also be done using switch case. But the what is the difference between if else if and switch case? That switch case only allow integer and character type of data to be the control or to be the control variable. Like you cannot match if this marks is of float type or double type, you cannot use it in switch case. Also, switch case is depends on the equal operation. It is depends on equal. That means you cannot have this greater than equal to or less than equal to sign. Okay, so let's check switch case. And here is a problem in switch case that is called fall through. You can check it there, but I'm not going to discuss a fall through here. There is a problem called fall through, and for that we use break in between the switch case statements. So what we have here, we have switch uh, control variable, and then yeah, so and then value, sorry, case value, case value, obviously with a break. Here are some statements. Here are some statements, and you can have as many number of values as you want or case as you want, and then you have default. Okay, so you can have this kind of structure. So what is happening in this particular situation? In this particular situation, the control variable will be matched with these values. Like you have this particular variable and they will be matched with one of these values, and for that particular match the statements are going to execute and the control will break out of the loop. And if any valid case is not found, then the default instructions or whatever statements that are inside this default section is going to execute. For example, suppose we have a number is equal to say 8, or rather suppose a number that is equal to 7. So what is the purpose of our code or the code that I am trying to write is depending on the number, you have to identify the day of week. Like for 1 it is Sunday, for 2 it is Monday, or for 3 it is Wednesday, something like this. So for 7 it will be Saturday. So to write that particular code, what you can do, you can write it switch the control variable. So control variable is the variable that is going to be matched with the case value. So switch number, so this is the variable that is going to match. Then case value, so case 1 print Monday, break. Case 2 print if Tuesday, break. Case 3 and so on. Then there is a break, and we have a default here, say print wrong choice, suppose, or wrong day, something. So what will happen? The control, suppose we can write case 7 here. So printf Saturday. So what will happen? Suppose control is here. Suppose instruction number 1. Then one of these instructions or one of the set of instruction is going to execute depending on this control variable. So this control variable will be checked with all the values. So if it is a character type variable, you have to put this. If it is a character type variable, if the control variable is an integer type, then you don't have to put those things. So the number will be matched with one of the cases. So first of all, the number will be matched with case 1. That means if the value or if this number is equal to 1, if not, this particular section will be skipped. If not, this particular section will be skipped. And similarly, all the steps or all the cases are going to be skipped, and until and unless they found this one. That means case 7. So after this one, the control will go to here because we have found number is equal to 7, that is equal to true. So this particular statement is going to execute and it will break out of this loop. So break statement and continue statement, they are used, so break is used in switch case as well as loops. Continue is only used in loops. So break statement is used to break out of a particular block in the sense either from switch case or from any loop block. So break statement is used for that, and continue is used to move forward to another iteration. So we will discuss that later. So for that, break is used to break out of that switch block. So after executing all the statements that are inside this case, you don't have to put any braces. You can press any number of statements in this case section, and those all the instruction on that particular case is going to execute and it will break out of that loop. But suppose if you have suppose 17 here, so if you have 17, what will happen after this particular statement? One oh sorry, so 2 will be here, and this is going to be 3, and this one is going to be 3, because we have not found any matched cases with this particular scenario. So from this section, what you can conclude that this number is going to check with all the cases. That means what I said about the limitations of switch case, that it only applicable for equal operation or equality operation, and we cannot check this kind of operations like greater than or less than or greater than equal to. That is not possible in this particular case. Switch case, and switch case is only applicable to integers. Switch case is only applicable to integers as well as characters. They cannot be applied for floating point or double type of data. So that is the limitations of switch case. So I guess I have to stop here. So we will continue from the iterations and all the remaining parts in any other class. So we will discuss or we will discuss the class date on WhatsApp. Okay, so I am stopping here.